Now let us continue with our discussion. In last video we had discussed about creating and displaying the linked list. Now we are going to display the linked list using recursion. For that I am going to write the code here. First of all, you know how the outcomes look like. So I'm going to what I'm going to do is I'm going to give the number of node that I need. Here 5 node I need, and I'm going to give all the node data, right? And we are going to print this one. This is what we have done till now. Now I'm going to write the recursive code, and same thing, let me write it as dr display to differentiate between the normal iterative display and recursive display. So after that, first of all, I'm going to write a end line, then I'm going to call display here, and I'm going to pass the first node, right? First node pointer. Then here I'm going to write the function, and I'm going to use the if. Normally if p becomes equal to if it is not equal to null, then we are going to print it. So it is data, so we are going to print it. Then after that I'm going to call the again recursion display function, but this time I'm going to send next. Okay, this is how it works. Let me explain what we are doing here. First of all, I will copy this code and I will paste here. So let me explain how it happens. Initially I have sent the first node, right? Here imagine we had node like this. We had 2 here. Sorry, let me make it big. So we have some elements here. Imagine we have some elements like 3 nodes we have, and this is null, and this is 2, and this is pointing here, again 3, and this is 10. Imagine like this. So first of all, we are going to call the first, we are passing the first, right? First is pointing at the first node, so we are passing through the function call, we are passing here. So after that it will check if whether it is null or not. Definitely it is not null, right? And it will pass the if statements, and we are going to print this one. We are going to print 2. After that, while the next time what I am going to send is the p next. That means this is p, right? This is p, this is a p, this is a local node, a local pointer node pointer, that is p, which initially had first node pointer value, so it will be at this point. But next time I'm going to send the p next. P next means this one. I'm going to send the next node to this recursion, to this function. So again it will go here, if statements, again it becomes true because p is not equal to null. So we are going to print this one. Next time we are going to send p next, that is the 10th the node which has the data 10. I'm going to send, and it will go again, and if will be passed, again it will be printed, and I will send p next. That means p next here is null. See, this is a pointer. If it is pointing nowhere, that means it is a null pointer, means it will be pointing to the null. So when I say p next from here, p is here, p next means null. So if I send null to this function, if p isn't equal, if p is actually null, right? P is actually null, so it will be failed. So that is how recursion ends. And let us check our code whether it works or not. So I'm going to give 5 elements. Those are 1, 6, 2, 3. Let me take 10. So again we are printing the recursion display. So this is how recursion works. So let us do same thing, but now let us count the number of elements, number of data that node contains. So iteratively I will do first. So count I will take, that is iterative count, and I will pass again fi is first. So there I am going to write the function. Imagine we actually let us send the integer value from the function, means let us print here how many uh, elements we have. Let us print here. Okay, so our function should return int. So I'm going to take int again, I count, count count, then again p, some local pointer. So how to count? See, it is just similar to what we have did in the previous class. That is, you know how display works, right? Same thing I'm copying and I'm pasting it so that we can understand how it works. It is actually, if you learn how display recursion works, how the normal iterative display works, that is iterative display and recursive display. If you know that how it works, all other will become easier. So let me copy this one. So you will be knowing how it works. So instead of printing, what I do is I will increment the count. So count I will take initially as cnt is equal to 0. So I will increment, then I will pass to the next node. So I will pass p until the null is until we reach the null node. Okay, then I will return cnt. So this is how it works. So if I print, so let me print it. So I have 5 elements. Those are 1, 3, 7, 8 and 10, and I should get 5, again 5. So let us move forward and see how recursion works. Recursion, for that I am going to copy the same line, but r recursion I am going to write a function for recursive count. So r count I am going to give for my function. So int r count, count, again the some local pointer that points to the first node. Then you should know how recursion works first of all, right? If you know how recursive trees are formed, then that will be easy. I am going to explain you that one. So first of all, if p means if it is not null, you can just give if p, there is no problem in that. Just for our understanding, I am going to give p isn't equal to null. At that time, what I am going to do is I am going to return r count, count, then again p next I am going to send, then +1 I am going to do. So I am going to explain you this with recursive tree. If I find null, then what I do is return 0. This is what I do. So if I run, then I should get again 5. If I give 5 elements, I should get 5. So 5, 1, 5, 2, 3, 4. So I am getting 5. So how it works is, let me write some recursion for this. Imagine we have 2, 3, 10. Again same elements we have. So we need to count this one. So let us take our code so that we can understand. Okay, I am going to take the count, okay, and paste it here. Let me remove this one. I think it is not required now. Okay, I'll move this here. Before that, I will erase this thing. Okay, we have, okay, let me draw the recursive tree. Let me remove these things. Okay, now I am going to draw recursive tree. So imagine first we are passing here, if you see the code, that first we are passing first, right, the first node pointer that we are passing. So I'm going to write like r is our function, r count. Instead of writing r count, I am writing r just for our convenience. I am going to first pass the first node, right, the first node is 2, so I am passing 2 here. After that, if it is not null, definitely it is not null, then it should return me r of p next. P next is nothing but this one, that is 3, so it should pass me this and plus 1, it should be done. So it will be done after it will actually while coming back, while returning this, one will be added, will be not added at this time. So for our even it will work, definitely it worked, right? But let us add 1 year, that I can explain you this. Okay, now I am going to add 1 year, so let me change this also. Okay, I am adding 1 year. So I am going to explain you how return type will also work. But first, let me explain the simple thing that we need to understand here. That is, 1 will be added, and again the call for the R3 will be done. So R3, then again it will go here. That is, at P we are sending this node. So if it is not null, then again return 1 plus R count of next, P next. That means the next node will be called again, right? I am going to call the next node again 1 plus R of 10. After that what is there? Again I am going to send the 10 here, the node 10 I am going to send into this function. So again it is not null, right? The next of the 10, the node which is there next to the 10, that is this node is, imagine this is a node, it is null, but this is not null. So if condition will again be satisfied, so again I am going to return 1 plus R of that one. Okay, 1 plus R of, like again the next P next, it is nothing but null. Let me take it as a 0. So I have taken this as 0 because it is null. So again I will pass the to the function R count. So if statement will fail because P is again pointing to the null, it is not pointing to the 10, it is pointing to the next node which is there at 10. So we are going to go to else statement and we will return 0 there. Okay, now I am going to return 0. So it will be returned here. 1 plus 0 will be 1 and this will be sent here. 1 plus 1 will be 2 and this 2 will be sent here, and 2 plus 1 will be 3 and 3 will be sent here, and we are going to get 3. That is how recursion works. So you need to practice for more. It is so much important to practice by writing recursive tree so that other bigger problem can be understood easily. So I have counted. Let me do sum of all the nodes. First I am going to do iteratively, COUT. Let me take I sum, that means iterative sum, FIRST first, then end line, then I am going to write function for that also. It will be returning int I sum, again it will take some dummy pointer, and again I am going to do same thing what I did for the count, right? Instead of this, see, I am going to copy this. I can show how similar it works. So we have the function for count. So I will take it as a sum so that we could understand. Sum, it is initially 0, but while entering, what we need to do is we need to sum up with the data. So that is what we need to do, and while returning also we should return this sum. So it should work for us, right? If you know I count, then you'll definitely know how I sum will work. So we should print this one here. So if I print, let me take like 4 values, 1 2 3 4. What is the sum of this? It will be 10, right? I should get 10, so I'm getting 10. So this is how sum will work. Let me go for R sum, that means recursive sum. Let me do here. I will take it as a R, then again I will return int R sum, then node P, then again int initial. If see, if P isn't equal to null, right? Null. If it is not equal to null, what I'm going to do is initially I would have taken like sum is equal to, since it is recursive, let me take like this. I will do sum plus what for count, what we have done. We must know how what we have done for the count, right? For count I have added 1, because we should count, means we should increment the by 1. We should let me show the tree how it works actually. See here, we were adding with the 1. Why? Because we needed count. But this time what we are going to add is p data, right? P data we are going to add, that's it. Nothing we are going to change. P data, instead of 1 we are going to add p data. Again I am going to explain you with the recursive tree, but let me write the problem, and then it is same as the R count. So I am copying this one, I am pasting this one. So instead of 1 I am writing p data. Okay, it should work if is how it works. So I'm going to run. I should get 10 twice, because I'm going to give 1 2 3 4. So 10 to, okay, we are getting 4. Need to know why, right? Like some R sum I'm calling, and then R sum here. So p plus count. See, count, it should be sum, right? I did not change. That is what happens if we copy. Then I should get 10, I think. 4 1 2 3 4 10. I'm getting 10 twice. That means we have done properly. Now again let me tell you one before the next video. Like next video we are going to discuss about insertion, deletion, reversing the linked list. Before going to that, I have said you there is two types of recursion, right? One thing is you are going to at one place you are going to add 1 year. That means while you are traversing down, at that time you are going to add 1, right? If you add 1 year, like if you add after calling the function, obviously logically it should first call the recursion, first it will call the recursion, then it will return. After that, with that return type, with that return value, it will add with the 1. That is how it works. That is what I was trying to tell. Okay, that is how it works. So what if in display, recursive display I have done, right? It will work like this itself. But what if, let me show the code. So here we have recursive display. I am printing, then I am calling. I am printing, then I am calling for the next node. What if I call, then I will print? Like literally I will call first, right? I will call this first, and I will print afterwards. That means calling will take first, the recursion will reach the end of the end just by calling without printing anything. While coming back, while returning, it is going to print. That is how it works. So at that time, if it starts to print, what will happen? It is common sense. It will be printing from backwards. Means we are printing reverse. Uh, we are not. We are printing the data of the node in reverse fashion. So if I run this code, right? If I run, I should get a reverse printing of the linked list. So there are 4 values again, 1, 2, 3, 4. So if I do this one, see, there will be reverse of this display of the linked list. So that is how recursion works. And you can watch other videos in YouTube which is made by others. Hopefully I would be not making that one about recursion. It is so much important. If you are so much interested in solving some program like you want to compete in some platforms, or even in internship test, and even in some placement test, they are going to ask more question related to recursion. Actually, they are going to ask about dynamic programming. So for dynamic programming, recursion is so much important, and I prefer you learn recursion and be strong in that, so that you can solve all other problems. So thank you.